All right, cosine inverse of negative radical 3 over 2 is?
It is what it is.
Good job.
5 pi over 6 is correct, so good job. Sine inverse of negative radical 2 over 2?
Negative pi over 4.
Negative pi over 4, very good. All right. Good, good, good. So, today we're doing a little more. More with inverses.
Oh, great.
Example 1, find the exact value of the expression. And hint, draw a triangle. These are actually nice and easy. Mm-hmm.
Heck yeah.
How many examples? Just one?
Okay, so I have secant of tangent inverse of 3 over 2. And these are nested. We have a function inside. This is a composition of functions. Order of operations says we start inside the parentheses, and we are going to do that. We're actually going to start on the innermost set of parentheses, and we're going to figure this out. Now, when we have an inverse function like this, it's asking what angle has a tangent ratio of 3 over 2. And I can actually draw that. And 3 over 2, so thinking about our unit circle and tangent inverse, which half the unit circle do we care about for tangent inverse? The right half.
But with little openings at the top and the bottom.
Okay, so yes, very good. So not including pi over 2 and negative pi over 2. So this is a positive ratio. So I'm going to draw an angle. This is an angle in standard position. So here's my initial side. Since it's positive, I'm going to draw my angle in quadrant 1 here. So there's the angle. What do you suppose I can do? Drop an altitude. Yes, we've done this billions of times before. So dropping an altitude, and once I drop that altitude, I can label some side lengths. What's the red side?
It's 3.
3, And the adjacent side would be 2, because that's what they told me. The tangent ratio opposite over adjacent, 3 over 2. What do you suppose I need to do now? Find the hypotenuse, the third side. See, you've done this before, right? Nothing new here. 2 squared plus 3 squared equals our radius squared. So
13.
radical 13, very good. Radical 13. So there it is. There's the angle that has a tangent ratio of 3 over 2. We did it. So now we get to find, hey, what's secant of that angle that we just drew? So what is the secant ratio according to the angle we just drew? Secant is?
Yes.
Reciprocal cosine.
1 over 2 radical 13 over 13.
Bless you.
So hypotenuse over adjacent, which would be radical 13 over 2. That's it. That's it. Drawing the triangle. All right.
That's literally all we have to do.
That's it. All right.
Heck yeah.
Cotangent of arcsine of negative 2 over 3. So arcsine, what is arcsine? It's the same as sine inverse. So this is sine inverse. So again, we're starting inside the parentheses here. And this is asking what angle has a sine ratio of -2/3. So I'm going to think about a picture. For sine inverse, which half of the unit circle do we care about?
The top.
The right side.
Right, yeah.
All right, this is a negative ratio, so top or bottom?
Down.
All right, so I have an angle in standard position. That's down here in quadrant 4. So here's my angle. And what do I need to do? Drop up in altitude. All right, and then I can assign some labels. Sine is opposite over hypotenuse. So my opposite side should be?
-2.
And my hypotenuse is? 3. And then we need to?
Right there.
The Pythagorean theorem. Good. So x squared plus -2 quantity squared equals 3 squared. X squared plus 4 equals 9. So x equals radical 5. Good. Positive radical 5. So there it is. There's the angle that has a sine ratio of -2/3. So the question we have to answer is, what is cotangent of that angle that I just drew? Adjacent over opposite would be? Good. That's it. One more. Okay, questions on these two? Question. Same thing as inverse. Find the exact value of each expression. What's different about these? Oh, this one is sort of a different order, yeah. These are unit circle things. The other numbers weren't friendly unit circle numbers. When I look at 5π/4, I think unit circle right off the bat. Radical 3/3. I don't understand how that could be radical 3/3. I might have to draw that one. Yeah.
Yeah. I skipped it. Yeah. I was just like,
Yeah. So this one I'd have to draw a picture of, I think. Okay. Let's work out this one. Again, we sort of can work through these things. So I'm going to start inside here. Thinking about my unit circle. 5π/4 is taking pi and dividing it into pi divided by 4. Okay. And whatever I do to the top, I do to the bottom. And so then I get to count. So 1, 2, 3, 4, 5 π/4 is right here. So there's 5π/4. What ordered pair is that? Okay. And so then what's the sign at 5π/4? Negative radical 2/2. So negative radical 2/2. And now we get to move to the outside function here, which says, hey, what angle has a sine ratio of negative radical 2/2? Now this is an inverse function. So I have to think about my unit circle, and since it's inverse, which half of the unit circle do I care about? the right half, so everything out here on the right side. Now this is negative radical 2 over 2, so that should be from down here, quadrant 4. So what angle? Negative pi over 4. Very good. So negative radical 2 over 2 always occurs at the pi's over 4, right? Okay. But I get to ignore the left half. So this one was positive radical 2 over 2. Down here is negative radical 2 over 2. So this is my angle that I want. The negative direction, pi over 4. Well, it can't be over here because this is quicksand land. Yeah. All right. Letter B, cotangent of cosine inverse of negative radical 3 over 3. If it was radical 2 over 3, I'd be great with my unit circle, but this one is not. But I can draw the angle. So it's not from my unit circle, but I can draw it. This is cosine inverse. Which half of the unit circle do I care about? Top. All right, so I'm just drawing this in the top half. Should I draw in quadrant 1 or quadrant 2?
2.
2 because it's negative. So my angle is opening up and landing in quadrant 2. And I get to drop an altitude. So there's my reference angle. And I can give some labels. Cosine is adjacent over hypotenuse. So the adjacent side is negative radical 3. And the hypotenuse is, and then we need to, the Pythagorean theorem again. So negative radical 3 quantity squared plus y squared equals 3 squared, which is 9. What is radical 3? Just okay, good. Just checking. So y equals radical 6. Good. Radical 6. Very, very good. And now we can figure out now what is the cotangent of that lovely angle that we just drew. Adjacent over opposite. Oh, this is really interesting. Adjacent is negative radical 3 over opposite.
That's double radical. That's 2 radicals.
That means that because the radicals cancel out.
No.
But does that radical move to the bottom?
You can't square the whole thing because
Does
you'd be
the
squaring
negative
the
radical move to the
cotangent
bottom?
also. This is a really good question. You're good now? Watch this. Hey, here's something interesting. Radical 6 is radical 2 times radical 3. Ooh.
Negative 1 over radical 2.
So the radical 3's will reduce. Ooh. So negative 1 over radical 2, which then we need to rationalize.
So if I did that like a normal fraction, I still would have gotten negative.
Negative radical 2.
No, I've never even
I'm learning.
This is an interesting trick that doesn't come up very often, so I'm happy to have shown that to you. Okay. you know. All right. Any questions for me? All right. Have fun. This is not what I was expecting we're doing today. So, okay.
You didn't know we're doing this?
I did the notes a long time ago, so. All right. Please remember that your project is due on Tuesday, so you should be working on that. And if you know to turn it in on Monday, that would be totally fine also.